Hello! I've been playing with relays and shift registers, Arduinos and real-time clocks, because I'm making a digital timer. It's for me to use to control some grow lights that I've got in the utility room, where I'm bringing on some tomatoes and peppers, getting a head start on the season, because I am also quite a keen gardener. So I don't have a greenhouse, unfortunately, and I absolutely need to get one. But for the moment, no, I don't have one. And at the moment, I'm controlling my grow lights on one of those segment timers. Um, and they're all right. They're pretty cheap and cheerful. I think about £2.50, something like that. And they last about as long as you would expect a £2.50 piece of clockwork to last, which is to say not very long. They make a strange rattling noise, or at least one of them has started doing so, and I have had them fail on me. They fail relatively regularly, and I believe last time I had one fail, I did actually lose a few plants, which I'm choosing to see as a positive thing because they were weak. But I'd rather not have it happen again. And I've, I'm looking for something a little bit better, really. Now I have had this relay module sat in my parts box for a few years now, actually, and I thought I could finally put it to some use. Now, the relays do say that they're rated for 10 amps at 250 volts. I'm certainly not going to be putting 10 amps through one of them. The highest load light I have is 450 watts, which I believe works out at about 1.8 amps, or 1.9 amps, on 240 volts, which is what I believe we run here. I think it fluctuates a little bit, but so yeah, I thought I'd give this a go. Now, I do have one minor concern, which is that I would normally expect, where's my tiny little screwdriver that I can point with, that'll do. I would generally expect something like this to have an isolation slot cut in round there, or at least to have brought that track a little bit further away, because this is the low voltage DC. So these are the resistors, the LEDs, and the transistors. Those bits there. These two are the relay coil contacts, and then these three are the terminals. Now, if I intend to run 240 volts through there, the lack of any kind of isolation slot there, I don't know. Does anyone have any idea if that would end badly? I mean, there's no ground pour. I'm not sure what the distance between those is. I think this is a 4mm tip screwdriver, I think. Yeah, about that. So yeah, maybe 3 mils clearance. Yeah, it might be fine. it might be alright, it might not explode. But I'll give it a go, see what happens. I think if it doesn't arc immediately, it's probably not going to, unless there was some kind of major surge. Might put a surge protector on and just try and protect the whole thing. That said, I'm not entirely sure how good any of those things are. So I use this, and I've got three 450 watt CFLs. I've got another 300 watt that's off in the other corner. I've got a couple of bug zappers, a fan, and I don't know, a spare. I might wind up with a pump for watering them, perhaps, if they get any bigger. I'm using an Arduino Nano at the moment. And what is this? This is a DS3231 real-time clock, which I believe is the bigger brother of the other slightly more common 1307, I think 1307, 1507, something like that. Where is it? I think it's 13. Can we see that? Oh, it's right there. Well, it's still screen. Yeah, 13. Well, I wasted more time than I should have on that tiny little detail. I'm trying to keep these videos short. Yeah, I have an 8-bit serial in parallel out shift register, the 74HC 595, which I just should always have a whole pile of because I just keep using them. Quite handy. And what happens is I was trying to think of some clever way of, storing the timing data. With like, I don't know, binary trees and all that kind of stuff. And I just realized that actually it's so much easier if I just replicate the thing that I'm replacing. So it's better but similar, the same but different. So I've just, like the segment timers, divided the 24 hours into 15-minute slots. Each slot is calculated, the time is calculated, multiply the hour by 60, add on the minutes, and get your modulus and find out which 15-minute slot you're in. That gives you a number between 1 and however many, or 0 and however many. Use that as the EEPROM address and read a byte from there and just write it straight into the shift register. So that's all it's doing at the moment, and this is just some code that I knocked together very quickly last night. Part of the reason it took me so long to put this together was because I spent quite a fair amount of time faffing around with these ESP8266 WeMOS modules as well, because I wanted it to be IoT, and I still do would like it to be IoT and to be able to, override things and, do all that kind of unnecessary, silly stuff that I probably don't have a legitimate use case for, but it's cool and I've got the things. But I found that there's an interesting issue where when I'm using this real-time clock with the ESP, when I set the time, I have to disconnect the ground and take this out and then reconnect it in order for it to have taken effect. Now I'm reprogramming the time through the serial, so you send a character and it goes, oh, you're changing the time. Give me 2 digits for the hour, 2 digits for the minute, 2 digits for the seconds. Boom, there you go, set. And that would just call the set time function in this RTC, and all subsequent calls for the time would have that new time set. Now, that works just fine here, and I'm using the dedicated hardware SPI pins, and I was doing so on this module as well. And this one works fine. I don't need to disconnect anything to get it to refresh, as it were. But this one does. It requires me to disconnect it, which is a bit annoying. Now that I've figured out what was going on with this thing, turns out, it's just the cable was a bit dodgy. I will try and see if I can replicate the problem on this module, and that'll at least tell me if it is a thing that's just down to these WeMOS modules, or if maybe it's something in the ESP AI, Smart AI Thinker, whatever the company that makes these modules is. So yeah, I'll give that a go and try and reproduce the problem. For now, I'm thinking this will just be a straight up 8-channel digital timer, like the the segment timers, and it will just have a serial interface to it with a few commands that will allow you to set the time and to program the sequences and what outputs you want to be on during which segments. So yeah, that's what I've been up to.